Hey, good day, guys. You're welcome again to my channel. I am Joshua, the designer, and in today's video, I'll be showing you how to analyze a plane truss. All right, so we'll be dealing with analysis of plane trusses in this video. All right, so I want to show you basically there are about four methods of analyzing plane trusses. All right, so I'll just like to show you what methods there are on the analysis of plane trusses. All right, so we have the method of joints, and in this video I'll be showing you basically we'll focus on the method of joints. All right, we have method of section, all right, then we have method, graphical method, graphical method of analysis, and we also have computer based method. So you can use computer based methods. All right, based method. Okay, so in this video we want to concentrate on the method of joints. All right, so these are the steps for the method of joints. So if we want to go by the method of joints, you have to bear in mind the following steps. All right, okay, so the step one says determine the support reactions. Okay, step two says inspect the truss to find a joint where there are only two unknown forces. All right, this is appropriate starting point. Step three says you draw the free body diagram of the starting joint, that is the joint you have selected as the appropriate starting point, to indicate the unknown member forces. Assume each member is subjected to a tensile force. All right, you may want to pay attention to all of these things. Then determine the unknown member force. Step 4 says look at the joint adjacent to the analyzed ones. If there is one which has only two unknown forces, then repeat step 3, which is the one before this step. Continue until all the member forces have been determined. If you do not understand what I just said as the 4 steps now, do not worry, as I'll take you one after another till we get our solutions. So we have a practical example to show all of these things we have just said. Okay, so this is a problem that we are supposed to solve. All right, so this is an example of a truss, and we are asked to determine the force in each member of the truss. And also, we are to state whether it is in tension or it is in what? Compression. Okay, so let's go together step by step to see how we are supposed to start here. From our previous steps, we said the first thing is to determine the support reactions. So what are supports? Basically, supports are as seen in joint A and joint B. This is support at joint A, support at what? Joint B. All right, that holds the frame to a point of support. So these are the support positions. Okay, so we are supposed to determine the support reactions. Now, before we will be able to do this, you have to have an understanding of reaction forces, all right, support and the support reactions. This is how I mean. There are three basic types of supports that we have. Three basic, I said basic. we have the fixed support, which is represented or denoted as this. All right. We have the hinged support or pinned support, and this is denoted as this. We have the roller support, and that is denoted as this. All right. For some, you see something like this. See, so that's roller. Okay, so these supports have basic reactions. Okay, so for fixed support, we have three reactions, and the reactions are moment M acting at this particular point, as seen. All right, the vertical reaction, we may call that Ry, and the horizontal reaction. So these are the reactions operational at a fixed support. For the hinged or pin support, basically there are two reactions. All right, the first of it will be the vertical reaction, and the second will be the horizontal reaction. Okay. For roller support, we have basically one reaction, and that will be the vertical reaction. So this understanding will help you get along with finding your support reactions. All right, the value for your support reactions. And can we just go ahead? And this will be done if you be able to draw out the free body diagram of this truss as seen. Okay, so let's go by that quickly so we have our result. So I want to draw this. So this is a pinned or hinged support, and like I said, we have two reactions. So I call this HA. All right, so another person might call it RX, however it is that you so desire, but I want us to use this HA. Okay, and for this we have RB. Okay, then at point C, this is A, this is B. At point C we have 40 kilonewton force acting in this direction. Then we have our dimension, 3 meter and 4 meters. Okay, we may want to talk about the sign conventions before we go ahead, because the sign conventions will help you through your resolution. Okay, method of joint resolution is what I'm doing. So for the sign convention, can we just declare what our sign conventions will be before we go ahead? So for our upward forces or direction, the sign convention will be positive All right. While for the right hand anti-clockwise, or clockwise rather, sorry, right and clockwise movement would also be positive. Meaning if I have a force traveling in this direction, that will be positive. If I have a force traveling in this direction, positive. If I have a moment in this direction, that will be positive. All right, so that's been registered already, so we can apply that as we go ahead. All right, so establishing the three equations of equilibrium, saying the summation of upward forces will be equal to 0, the summation of moments about a point will be equal to 0, all right, and the summation of horizontal forces will be equal to 0. So the three equation of moment of equilibrium would help us through at this stage also. Okay, so what we do now is to obtain our support reactions. Okay, let's take moment about point B, not forgetting that our sign convention is this. All right, so we have 40 multiplied by 3 because we are coming back to point B, which is positive. All right, plus RA also gets to be 4 RA equals to 0. So from this we can obtain the value of RA to be minus 30 kilonewton, meaning that this direction of RA, as we have said now, will be in the opposite. Okay, for the second equation that says the summation of upward forces is 0, so we can take RA plus RB to be 0. Then we have minus 30 plus RB is equal to 0. Therefore, RB is equal to 30 kilonewton. I believe that's clear enough. So we have, for the third horizontal force equation, summation of horizontal force is equal to 0. Would have HA, which is this force here. HA, that's positive, plus 40 kilonewton above, that's for positive, must be equal to 0. Definitely, HA value will be minus 40 kilonewton. So we have just obtained our support reaction. So registering our result now, we can say RA is equals to minus 30 kilonewton, and that minus represents in the contrary direction as we have in the free body diagram. Okay, so if we correct it in the free body diagram, it becomes positive 30. Okay, so we have HA to be minus 40, and that negative also means the same thing as I've already said. Then we have RB to be 30 kilonewton as said. Okay, so we can just go ahead now. Let's get back to our steps and see where we are on the plan. So We have carefully found out the support reaction. All right. So we want to go ahead to find, in following step 2, we are going to inspect the truss to find a joint where there are only two unknown forces, member forces, and that will be the appropriate point to start our analysis. Okay, let's do that quickly. So I want to draw out our truss again, and we are going to insert the correct forces and their directions as we have obtained. Okay, I think this will be in the negative, and this also will be in the negative. We have 3 meters from the base and 4 meters apart. Our array obtained 30 kilonewton. RB obtained 30 kilonewton. The direction says it all. HA obtained 40 kilonewton. All right. So, and we have these. The next step is to inspect what joint has about 2 member forces that are unknown, and that will be the appropriate place to start. Okay, we have joint A. We do not know the member force on FAC. We do not know that on FAB. All right, and we do not know that on FBC. So if we pick joint B, will be correct. If we pick joint A, will be correct. There are also 2 unknowns there. There are also 2 unknowns on joint B, at joint B. If we pick joint C, will be correct. There are also 2 unknowns at that particular joint. So it means we can start from wherever we choose to. All right. So to continue, these trusses form an angle here, which in turn will be the same thing as the angle here. All right. But this figure, this triangular figure, following our Pythagoras theorem, the length of FBC will be the square root of 3 square added to 4 square, and that would give us 5 meters. All right. So that's the length of this hypotenuse, 5 meters. To obtain this angle, the value for that angle, we know that cos theta itself would be 4 over 5, which is adjacent over hypotenuse, adjacent and hypotenuse. The sine theta would be 3 over 5, all right? And that would be enough for us to start whatever we want to do. So I would like to start from joint C. Joint C. But there is an instructions as part of our steps, and let me show you quickly. It says in step 3, it says assume each member is subjected to a tensile force. And so we can say that all members or I can rightly say that assume all members are in tension. And we know that tensile force acts away from the joints, all right? So we can say this is in tension. This member is in tension. We can also say this member is in tension. Then we say also that this member is in tension. So with this is what we are going to analyze. So let's start from joint C. So I'm taking joint C as my first point. So bringing out joint C and the members connected to that joint, I'd have something like this. Joint C, I have this 40 kilonewton FBC FAC. All right. So we just will use two of the equilibrium conditions. All right. And first of which will be the summation of the horizontal forces equals to 0. Not forgetting our sign convention. All right. So that means we are going to have 40 kilonewton positive plus FBC cos theta being positive equals to 0. Those are the two forces we can resolve to the horizontal at the moment. So we have FBC, the cos theta we obtained before was 4 over 5 equals to minus 40 kilonewton. Therefore, FBC equals to minus 40 multiplied by 5 over 4, which will give us minus 50 kilonewton. Now, this negative is saying to us that our assumption initially is wrong or was wrong. Okay, so we have to make correction to that. So seeing that our initial assumption for that member was for intention, so it means the correct assumption should have been compression. So that member is in compression. All right. That's for FBC. So we have the other one, which will be summation of the upward forces to be 0. So we have minus FAC minus FBC sine theta equals to 0. Now we have gotten the value for FBC. The unknown is FAC. So FAC will be FBC, which is 50 kilonewton. But because we haven't changed the sign convention, the tensile assumption, we have minus 50. All right. Let me clean this. We have minus FAC minus FBC is minus 50. All right. Multiplied by sine theta 3 over 5 equals to 0. So with this we have minus FAC equals to minus 30. Definitely FAC equals to 30 kilonewton. So that has given us a solution for FBC and FAC. So the only unknown here unknown member force will be for FAB. So we can either pick joint A or pick joint B, but I would like to pick joint A. And joint A looks like this. We have 40 kilonewton, we have 30 kilonewton, we have FAB, we have FAC. All right. So summation of upward forces must be equal to 0, right? So we have FAC being positive minus 30 kilonewton is equal to 0. So FAC is equal to 30 kilonewton. All right. Which is telling us that our former answer from joint C for FAC 30 kilonewton is actually correct. All right. So that could be a check for you, but our concern basically is to obtain FAB. So this represents a check for us. So for summation of horizontal forces with 0, we'll have minus 40 plus FAB to be 0. So we have FAB equals to 40 kilonewton. That's in tension being positive. So the summation of summary of what we've done now is to have the member forces and the direction now. So we have FAC, which will be the same thing as FCA, is 30 kilonewton tension. We have FCB to be the same thing as FBC, the 50 kilonewton compression. FAB, same thing as FBA, the 40 kilonewton tension. So this represents our solution. So let's get back to the steps. Now we can see now continue until all members have been determined, and we have just done that and we have obtained our final result. So if you have any question as touching method of joint resolution or plain trusses together, you can use the comment section, as I'll be there to answer to your questions, to your comments. And do not forget to like this video and subscribe to this channel. Share with your colleague that should get better with structural engineering. Till we meet in the next video, I am Joshua the designer. See you. Bye.